Assalamualaikum warahmatullahi wabarakatuh and a very good morning. In this video, we are going to proceed with the next topic in non-parametric statistics. So the final topic in this chapter would be homogeneity test. The homogeneity test is the second chi-square test that uses a contingency table. So this test is used to test the claim that different populations have the same proportion of subjects who have a certain attitude or characteristics. In this situation, samples are selected from several different populations, and we are interested in determining whether the proportions of elements that have a common characteristic are the same for each population. So this is where the difference of homogeneity test and independence test, where if you can recall, where the test of dependence or independence test is to determine the independence of two factors. Meanwhile, for the homogeneity test, it determines whether two populations come from the same distribution, even if this distribution is unknown. So the sample size are specified in advance, making either the row totals or column totals in the contingency table is known before the samples are selected. So the null and alternative hypothesis can be defined as the proportion of people for each group are the same. So it depends on how many categories that you have, and then the alternative hypothesis would be at least one proportion is different from the others. So if the researcher does not reject the null hypothesis, or which means that we accept hash note, it can be assumed that the proportions are equal and the difference in them are due to chance. But when the null hypothesis is rejected, we can assume that the proportions are not equal. So the procedure for the homogeneity test is the same as the procedure for the chi-square test of independence. So now let's go through the example. The psychologist randomly selected 100 people from each of 4 income groups. So here we have selected 100 people from each of 4 income groups and asked them if they were very happy. So for people who made less than 30,000, 24% responded yes. So this is our first category. For people who made 30,000 to 74,999, 33% responded yes. And for people who made 75,000 to 90,999, this will be our third category, 38% responded yes. And for people who made 100,000 or more, this is our final category, 49% responded yes at 0.05. So this is the significance level. Test the claim that there is no difference in proportion of people in each economic group who were very happy. So all the values given here, percentage, are those who responded yes, which means that they were very happy. So this is our table. We just write down the table where we have 4 categories. This is based on the income and the number of people who saying yes. So each category here, we have a total of 100 people from each of 4 income groups. So which means that the total of this will be 100. This is also 100, 100, 100. Considering that 100 comes from people who said yes and no. So for the less 30,000 income, 24% responded yes. So which means that 24% out of 100 people is equals to 24. That's it. Yes. So no, okay, that say no would be 100 minus 24, which is equals to 76. Okay, so the method same for the rest of the category. So 30,000 to 74,999, 33% responded yes. So 33 out of 100 would be 33. So 100 minus 33 would be 67. And then for the 75,000 would be 38% responded yes, would be 38. So the remain would be 62. And the last one is 49. So here would be 51 said no. Okay, so now we have the frequency for each of the category, okay, for yes and no. So the next step is that we want to identify or define what are the hypotheses for this situation. So the null hypothesis for this problem would be the proportion of people, okay, for each economic group who were happy are the same. So which means that the first category, the proportion of this equals to the second proportion, third and fourth. So it will be P1 equals to P2 equals to P3 equals to P4. So I just rewrite this so that you can make a revision on this. So the proportion of people for each income group who were happy are the same. So this is our claim. Okay, the proportion of me who were very happy. So the null hypothesis would be at least one of the proportion, one proportion is different from others. Right, so I have listed the hypothesis. The next step is we can find the critical value. So remember that I have mentioned earlier that the procedure of the homogeneity test is just the same like the property of chi-square of independence or independence test. So we want to find the critical value, which means that we have to find the degree of freedom. Okay, so the degree of freedom using the same formula for the independence test would be the number of column minus 1 times with the number of row minus 1. Sorry, this one should be the number of row minus 1 times with the number of column minus 1. So here we have number of rows, which is 1, 2, 3, 4. And the number of column is 1 and 2. So 2 minus 1, so it will be 3 times 1, which is equals to 3. So that is our degree of freedom. And then the significance level for this problem is we want to test at 0.05. So 0.053 would be equals to 7.815. So this is our critical value. Next, we want to find the test value. To find the test value, which is chi-square, we need to know the expected value for each cell. Okay, so to know the expected value is we have to know the total column or total row or row sum, okay, multiply with the column sum divide by the grand total. So in our table, we already found the row sum. Here we have row 1 sum, row 2 up until row 4. So we need to find the column sum so that we can find the expected value for each of the cell. So here 24 plus 32 plus 38 plus 49 would be equals to 144. And for the second column, sum would be 256. And total of this would be 400. Okay, now to find the first row, first column, it will be the sum, the first row sum, which is 100, times with the column sum, which is 144, divide by the grand total, which is 400, equals to 36. Okay, same goes for the E21, the E12, first row, second column, it will be 100 times with 256 divided by 400, which is equals to 64. Okay, and then you can go through the next one. Is for E21, it will be 100 times 144 over 400. So the value would be the same for each of the column, and for the second column would be the same. So you can see the expected value for this one would be 36. And the expected value for the second column would be equals to 64 for each category. So now we have found all the values of the expected value. So remember, the blue color is the expected value and the red value is the observation value. So now to find the chi-square is that we have to find the summation of the observed value minus with the expected value over 1 squared over the expected value. So here would be 24 minus 36 square divided by 36, and then plus with 76 minus with 64 over 64 plus with 33 over 36, 67, and then 38 plus with 62, and the last one 51 minus 64 squared over 64. So the total of this would be chi-square is equals to 14.14. And we have our critical value, which is 0.053 is equals to 7.815. So based on the chi-square value, which is 14.14, here is greater than the critical value. So since it is greater than, which means that we have to reject H note. Where there is enough evidence to reject the claim, okay, where our claim is there is no difference in the proportion. So we can conclude that the income makes difference in the proportions. Okay, so that is our conclusion. So that's how we solve using the homogeneity test.